thank you for coming. I am Pablo Tesone. I work for the Pharo consortium that is part of INRIA and is part interrelated with the EBREF team. So we are working for developing Pharo and all the ecosystem and all the community and trying to push more. A little slide about me, nothing that I don't say all the time. You can ask me. It has been the problem is that this slide I use it all the time and the numbers are getting bigger and I don't know if it's good, but yes, it's nice. Well, here we are going to talk about desktop applications. So let's do a little demo. Let's start with a little demo of what we want to show, what we want to have. Let's start. I have downloaded my application. It's a little boom. My application, it's an installer. So if I open it, everybody that is familiar with using OS X know how this is normal. So I will just install my application. Now it's installed with the other applications in the system. And I will run it, this little game. And I have this, that is nice. So this is a game where we have to paint in colors the different cases to make it work. If I don't remember the rules, we can take and see the rules. We can see the rules, here they are. And I can try to finish. Of course, this is demo time, so it will be possible that it's not good. And I don't know where. I made a mistake. I don't know where. Beep, 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 beep. Well, I don't know. Okay, let's start another one because I want to show you what happens when I win. So we are going to do this all the day because I have to win. I am like the spoiled kid, so I want to win. I want to win. Well, as you see, we have an application that looks like, of course, it's demo time. I have it in the slides, so don't worry, I will show you. But it has an application that looks like any other application that we have in macOS. And this is what we want. We want to build applications, and we are proud of using Pharo, but we want to hide it. So let's come back. So you see it in real time. So what is our objective? That we want to develop multi-platform applications. We want to make them look like integrated with the operating system because it's what the users are used to use, are used to feel that they work exactly the same, that they are installed in the same way, that they are packaged in the same way, that they are interacted in the same way, that they can find the settings in the same way and the notifications. And we want, of course, it to be automated and we want it to be easy to do because why not? So we want always to develop in Pharo because we love Pharo. We find it really interactive, really cool, really fun to develop. And we want Pharo to be able to do whatever we want, whatever to generate the applications. I don't want to start opening Xcode and having to throw some Swift code inside and then making a lot of hacking to make it work. I want everything in Pharo. Why we want Pharo? Because we have a really rich ecosystem. We have a lot of frameworks, a lot of tools, a lot of libraries, and even the language is cool and the environment is cool. So we want to profit that and produce applications. As the people in Thales showed us before, it's a very productive tool to generate applications fast and to generate what the customer needs and to modify it on the fly. This already you know that. And we want to take advantage of them also to generate nice, cool, rich applications. Well, Just as a little reminder, in Pharo we can build applications really that look like native with the native widgets using GTK that looks like exactly what we want, or we can do applications completely different with our drawing us ourselves the widget or doing really crazy stuff with the low level tools that we have like Block, Spec, or even using Rosal or different tools that we have to generate applications. So we can have a best fit for all different kinds of applications that we can do in Pharo. And we need to fit the missing part that we were having, because until today I will not present how to generate an application with Spec or GTK or how to do it with Block or Rosal. I will show you how to pass from this application that we can develop, how we can package, how we can distribute it, and how make it look like and integrate in the system as any other application that we can produce with native tools for example, in OS X with Xcode, or in Windows, I don't know, producing it with Visual Studio. So I have taken this little application, this a little game. It was developed by a student. It's developed in Block. It's just an example. This can be done also for any other application, even can be done for wrapping and distributing an application done in Morphic or in Spec GTK or in Spec Morphic or whatever tool you use in Pharo. It's the same, just an example. And it's a really nice game. So thanks a lot for Enzo, because the idea was to take somebody else's code and see how much we have to modify it or how much we have to configure it to make it a real application. That will be the real scenario. We are going to take an application developed, you invest a lot of time on it, you have it all developed with all tests, really nice, very nice, and now we want to package. So, as I say, it's a nice application, and we are going to package it for Windows and macOS. Also, there is the opportunity to do it for Linux, but now we stay in the state that we have it for Windows and macOS. And we have to have a nice package application integrated in the system and with a nice installer for it. So, to have an idea of what we want, well, first, what we want is nice branding of our application. We don't want to, or yes, we want to show to the world that we are using Pharo, but we will love that our application has our icon and it looks like our application. And when somebody asks the properties, the metadata, it sees our information of the application that we are producing. We want to have seamless integration with the OS. In macOS, it's normal that the menu bar is integrated in the menu bar of the system, and it changes when I change from application, and it looks like, and it have a lot of nice features. Also, we want to have notifications when you win, that I couldn't make it appear, but it was there. And we want to have installers that look like and behave and feels like the one that the users are used to use. Nowadays, I can distribute my Pharo application and say, oh yes, you can have to download this, and run this script, and then execute this and put this in this environment variable or whatever. Well, I want to have it in an installer, and I want to have it that it looks like and behave exactly as the user wants. We want to have custom error handling, because it's nice, it's cool that when we have an error in Pharo, we open a debugger and we can hack and fix it. But for a real user, end user, we don't want that. So we want to hide all this handling of errors behind in a way that we can show, from showing a little pop-up message saying, there was an error, sorry, or we are going to restart or do whatever, to things more crazy, like logging them in a server, sending the stack trace so we can debug, or anonymizing the information. That depends, of course, in the application that you are doing. Maybe in my simple game, I will just try to die in a really nice way, like say, oh, we had an error, sorry, we are going to restart, or something like that. And we wanted it cheap and automatically, because it's what we want always, not spend time. So this is the plan of the steps that I am proposing to you to have this. First, we are going to start with loading our application code. That is basically, as we do as always, we are going to install our application without any difference. We are going to install all the dependencies, and for this, Metacello is nice, is good. I am installing, in this case, I am installing the version that I have modified from the Takusu game, but we are going to install it at the usual thing with handling the dependencies with the usual tools, handling the packages and our code and the usual way. That does not change and does not add any complication. Then, of course, we need to integrate our application in the system. This is the part that takes a little of modifying our application, because it depends how much you want to integrate in the system, how much you have to modify it, and also depends how much you want to be portable, because as you know, not all the operating system present the information in the same way, not all expect the same kind of integration, so we are needed to do some work on that. But Pharo, in this sense, is great, because we have a lot of existing libraries that provide this. These are examples that we can use to integrate. For example, the menu, I will show how it was done, the menu example, but it's using the excellent Objective-C bridge that allows us to communicate with all the Cocoa and all the Swift and macOS libraries, that thanks to Esteban. Then in Windows, we have a lot of really nice integration with the work of Thorsten in Pharo OS Windows, that as you have seen is also used in the previous project. So it's a really good package. And also we have a nice COM integration that, for example, allows us to integrate parts of our applications in another application. Something that we can do is, for example, try to integrate a Rosal presentation inside a Word document, and that we can do it using it, integrating it through the COM interface. So thanks a lot, in this case, to Esteban and Thorsten, that they are working a lot on this and producing things that we can use and we can integrate with the system. For example, it's as simple as the integration with the menus. It's all pure Smalltalk code, and we can do it. And if you see I will provide later the link to the modified project, but it basically says, yeah, if I am in OS X, I will do this. If I am in Windows, I will open the menu integrated in the window using Toplo. But basically, I am creating the menus, and I am creating the notification. As you can see, it's basically a pure Smalltalk code that uses the magic of the Objective-C bridge behind, but from our use is really cool. Then we continue with the plan. The idea now is to load part of the code that allows us to embed this image into an application, and let's say that have an embedded application, have something that we make a single thing, that we don't have the VM and as an application and the image as a document. Now we want to have both inside. And this is the idea of the Pharo Embedded Support Project. Basically, it's a library that provides a way of having custom error handling that extends the Pharo error handling, so we can have a single entry point for all errors. In this case, it provides a simple implementation that shows a pop-up when you have an error. It extends the command line handler, so we can launch directly our applications in a way that I can create a simple object that will be the entry point to my application. And it has a lot of generators that will generate the files that we need to execute in our CI process to do the packaging, the building, all the thing automatically. The idea is that we configure the tool, and then it will run and generate the scripts and the infrastructure that is needed to generate our application. So let's talk about that. That is the real meat in the talk. That is, okay, we are going to automatize the generation of generation of the CI process. So basically, we are going to start. I will show it first in OS X and then in Windows, but it's basically the same. We start configuring the generator with properties that are specific for the application, but also that are specific for the system. For example, we are giving a bundle name, we are giving the version, we are giving the file that has the icon set. In OS X, when we do an application, we have to provide different icons for different resolutions, so that's an icon set. And we provide all the information, the metadata that will be produced in the application, that in the bundle that we are going to generate. So we configure it, and what it will generate, in the case of OS X, it will generate a bash script that we can version, or we can generate on the fly every time. But basically this bash script will allows us to, using using a standard tool that is included in Brew, so we have to install some dependencies with Brew, but it will generate us an app package and an installable file that we can use directly as any application. So like that, we will generate an installable that we can distribute. I will talk a little later what is missing, or what it will be in the next step to have really something that we can distribute. But this is something that you can give and install, and it's an application that everybody can directly install in the system, and it will work as it is a native application. In Windows, we start with a similar configuration. Some of the properties are exactly the same because they are the same, but we have some information that is extra, and for example, that we are adding in the metadata of the executable file, because like that we produce nice executables with the correct metadata as I showed before. In this case, the process will generate two different scripts, one PowerShell script and one CMake script, because in Windows what we are doing is that we are taking the image and not having it as an external resource that is accessible, but embedding it in the executable. So we will generate a CMake script that will run and generate for us all the dependencies. It will download the correct VM, it will get the correct DLLs, and will generate the executable file of our application. That is basically the combination of the VM plus our image, all freezed in an executable file. And then we will have a PowerShell script that will generate this nice installable that is in a way that works exactly the same expected by the user. This PowerShell script can be extended to add additional steps, for example, defining environment variables, or copying more files, or adding whatever information we need for the user. For example, if we need to make choices during the installation. This work is not only my work. What I have done is I have collected many of the parts that were around in the ecosystem. So thanks a lot to Christophe that has automatized a lot of this work for using it in the Pharo launcher, because the Pharo launcher already has all this. But the idea now is taking a doc solution and providing a common single way of doing it. And thanks to Guille a lot, because there is a lot of work that we have done to automatize the build and make it simpler, the CMake, and make it easy to build. Boom. And then the last point that we have, where we can generate our application in our machine, but that is not really professional. We want to have something that we can automatize and generate in the CI, because if only I can produce the application in this machine, is a problem. We need to do it in a process that we can repeat and do it all the time. So basically what we are doing is having some GitHub Actions script that uses that starts from scratch from the source code. In this case, in the example, is taking a Pharo image, loading the application code and the dependencies that we are requiring. It generates the scripts and then upload the artifacts, so they can, in each build, in each commit, we can produce a nice artifact that we can download. We have the script available, of course, for OS X and Windows, and both are running nice, smoothly. As we can see, we have the CI build. In this case, we have a build for, we are seeing the build of OS X because it was green. The other has some glitches, so I show in the green, and it's producing a development build that it can be generated. In this case, just because of the infrastructure that we have in GitHub Actions, it's generating an Intel OS X application, but because it's an Intel machine, and the working machine in the CI is an Intel one, but we can generate also the the ARM version if we run the process in an ARM machine. So thanks a lot again to Christophe, to Cyril in this case, and Steph, that they have produced a lot of knowledge of how to write the GitHub actions and how to do the upload, how to produce the installers and execute the scripts in GitHub. In GitHub Actions, so thanks a lot. Again, I have extracted a lot of connaissances that were distributed in the community in different processes, and I have produced like a packaging that can be used easily. So you can access the example. Is there? It's all the code. It's all the scripts. You can use it and you can play with it. There is the integration with GitHub Actions. There is the integration on OS X, and produce the embedded window app. This case is a blog application. My idea is to produce another example with an spec GTK application. I got out of time before the conf, but the idea is to produce it sooner and to have different examples of how to package applications. So of course, it's open to improve and to copy. You can use it as a base or not, or throw it away, or tell me how to we can improve and make it better as an example. What are missing, or what is the future and where we are going to go for the tool itself, for the support and the we are going to change the name. We need a fancy name still but this is the actual repository with all the code, so you can access it. The future that we have in mind is adding a UI, so we can generate these scripts to configure the distribution in a better way, add more things that we can configure from outside, and having more nice support in the generators. The idea also is to continue pushing to build the projects from minimal images, so directly not only not using the tools, but directly don't have it in the image. There was a lot of work on that. There is a lot of work done by different members of the community. We need to extract that knowledge and give it some handling to make it reproducible for many cases and make it more general, but we need to work on that because it still requires some manual work for each process, and we want for each application, and we want a cleaner process. We want to move the generators maybe outside the image, so they are not packaged in the final image of our application, so we can have a smaller minimal image. And we want to continue working on the scripts to add the idea of trying to automatize as much as possible, because the tools does not allow so much, but to automatize the signing or notarization of applications. That is basically really important nowadays, both in Windows and OS X, to give our users the security that they are installing the applications that we want to distribute to them. And of course, as usual, more documentation, more examples. That is a ballet that is everywhere, but we are going to continue working on providing examples. So thank you so much. These are the two repositories you can access. The first one is the full example. A little disclaimer, it's broken now, but because I have broken doing some changes just to have a nicer version for the presentation, but my idea is to fix it up in this week or next week, so to have it back up and running with the automation. It's broken when you try to generate the build in the GitHub Actions. Locally, it builds, so I don't know why the difference, but we have to debug that. So thank you so much for your time, and well, if you have any question, you are open. Yes, Annie.
How is it possible to remove code changes?
The idea is not to remove code. The idea is that nowadays loading the package, what it does is that completely disables the generation of code changes, and the code and the sources is not needed. But what we want to do as a strategy is in the other way around, is starting from an image that does not have the tools that we don't want, in this case the code changes or the debugger or whatever image, and load only the things that we are using on demand. That requires some cleanup from our side in how the Pharo image is done, because we need to modularize it better so we can express better that what part of the code we need for loading our application. And nowadays, as I say, the examples that start from a really minimal image are ad hoc, in the sense that they care little by little care what to load or not to load, but we want to improve that. Nowadays, what I am showing in this example, what it's doing is disabling it. It's not unloading the code. The idea is to not have it the code at all, not even disable or remove it. The idea is to start, you create your application, you create your metacello description of your application, and load it in a fresh basic or minimal image. So like that we can try to do that. Of course, if you already have ideas or you have an application that we can start working on, we are, as everything that we do in the consortium, we are open to the community, and this is work guided by the community. So that if there is something more that you want to push, is open to, we are open to talk about that. But the idea basically is not removing the code, but not having it at all from the first time.
I tried packaging Pharo applications for the Linux distribution I use, because they were unpackaged. And an issue that I encountered is during the dependency downloading, usually Pharo applications have a metacello definition, and you have to execute code so that it will automatically pull the dependencies. But my package manager does not allow connection to the internet. So what it expects to do is that the dependencies are declared somewhere, and I fetch them before executing code, and then I pass them to the builder, and the builder does it self offline. Is there support for this kind of building procedure plan?
When we are doing well, again, we need to make it general. We have this similar problem when we are bootstrapping the image, because we need to have all the code downloaded. Basically, not because we don't have access to the internet in the bootstrapping machine and the bootstrapping CI, but because we don't have the tools to load code from when we start from building the Pharo image, we start from a small image and we start loading things. In the small image, we don't have support to downloading or doing a clone of a Git repository, so we are in the same case. What we are doing in this case is that the dependencies are, we have a previous step, a previous image that downloads all the dependencies and generates it in a tree, so the build process can run on this with all the dependencies. As I said before, still we don't have a general solution for that. We have an ad hoc solution. I can guide and show you how it is done, but eventually, if there is more and more interest on that, we can try to generalize it and do it a version plus more general. The other solution that we have for the in Linux is that Esteban is working a lot on that, and we want to keep it working, because it's complicated, because there is so many distributions, to have different packages for each distribution. For that, we are using OBS, Open Build System. That is a really nice tool and infrastructure provided by the SUSE distribution. That allows us to generate packages for a lot of distribution now. And well, the idea is to generate that this idea of generating and packaging application, we want to generate using it OBS and supporting that already handles the particular, for example, it handles the problem of generating an RPM, a valid RPM package or a valid the package, and all the particularities that it's not just the packaging of the dev or the RPM, but also where you put everything in different places, where the logs go in each distributions and so on. So that is the path that we want to go. Again, we have nowadays ad hoc solution for that. If there is interest and from the community, or we want to generalize these solutions. We have seen now that the great interest that is guiding us are Windows applications, but also we have seen that there was a long-hanging fruit for having OS X applications, so we started from there. Okay. Thank you so much.